Here is a numerical type question. Work through the numbers carefully. Let us solve it step by step. Let us first understand the key concept here. Structural isomers, also called constitutional isomers, are compounds with the same molecular formula but different connectivity of atoms. C6H14 is a saturated alkane, CnH2n plus 2, N is equal to 6, so we enumerate all possible carbon skeleton arrangements. Moving on to the next step. Identify the degree of unsaturation. Du is equal to 2 times 6 plus 2 to 14, 2 is equal to 0, confirming it is a fully saturated acyclic alkane. Moving on to the next step. Systematically enumerate all distinct carbon skeletons for hexane, 6 carbons. Isomer 1 N-hexane, straight chain of 6 carbons. CH3CH2CH2CH2CH2CH3. Isomer 2 methylpentane, 5 carbon main chain with a methyl branch at C2. CH3CH, CH3, CH2, CH2, CH3. Isomer 3 methylpentane, 5 carbon main chain with a methyl branch at C3. CH3, CH2, CH, CH3, CH2, CH3. Isomer 4 2-dimethylbutane, 4 carbon main chain with 2 methyl groups at C2. CH3C, CH3, 2CH2, CH3. Isomer 5 2-3-dimethylbutane, 4 carbon main chain with methyl groups at C2 and C3. CH3CH, CH3, CH, CH3, CH3. And for the final step, check for any additional isomers. A 3-carbon main chain would require 3 methyl branches totaling 6 carbons, but 3 plus 3 equals 6 with 3 methyls on propane is neopentane-like. However, attaching 3 methyls to propane gives C3 plus 3C is equal to C6, which would be 2,2-dimethylpropane. But that is C5H12, not C6H14. No valid additional skeletons exist. N-hexane, 2-methylpentane, 3-methylpentane, 2,2-dimethylbutane, 2,3-dimethylbutane is equal to 5 total. Therefore, the correct answer is 5. Therefore, the correct answer is 5.